Behind the ordinary objects which surround us in our day-to-day lives lie something extraordinary. Incredible stories of ingenious solutions to problems most of us never knew existed. So what mysteries are concealed in everyday things we take for granted? Concrete, the mobile phone, light bulbs, steel, and traffic control. 5 ordinary things, 5 extraordinary stories, now revealed as we go behind the scenes, inside the machines, to find out, how do they do it? It's the stuff cities are made of, and next to water, it's the world's most heavily consumed product. Concrete is the revolutionary invention which made the modern world possible. For centuries, we've had to build with unwieldy slabs of stone. Now, we use concrete for everything from hydroelectric dams to pavements. But producing concrete is complicated. You need a lot of explosives, some giant quarries, huge ovens, and from making it to laying it, you're in a desperate race against time. It's dawn in the port of Tarragona, Spain. They're planning to extend the pier using bricks. But not any old bricks. These will be the largest concrete bricks in the world. Measuring a phenomenal 60 meters long, 45 meters deep, and nearly 30 meters wide, each brick takes up the space of 30 Olympic-sized swimming pools stacked one above the other. Each one weighs a staggering 30,000 tons. So how do you make a humongous 30,000-ton mega brick? Well, this one started life 10 days ago as a metal platform, a bit like a giant wire brush, which was towed underneath this extraordinary machine. It may not look like it, but we're beneath a ship, the Kogira. This bizarre vessel has been specially designed to make the biggest bricks in the world. But to make them, it needs the most gigantic quantity of concrete. The main ingredient of concrete can be found all around us: rock. But concrete requires different kinds of rocks which combine in a particular way. In the trade, this combination of rock is known as aggregate. Believe it or not, every year, without even knowing it, the average family consumes 3.5 tons of aggregate. That's because, strange as it may seem, it can be found in everything, from chewing gum and window panes to toothpaste. To make concrete, you need aggregate, sand, water, cement, and some high explosives. This is the Lafarge Mount Sorrel quarry in central England. It covers 750 acres, is up to half a kilometre deep, and is the largest granite quarry in Europe. No less than 5 million tons of granite is blasted from these hills every year. Granite gives concrete its strength. But getting the stuff out of the ground is a dangerous business. Every day, the blasting team packs 4 tons of high explosives into 12-meter boreholes, carefully drilled into key sections of the quarry face. Then the holes are filled and wired. To contain the impact of such a large blast, the timing of the detonations is staggered by a few milliseconds. Once the explosive and detonators are set, the site is cleared. The only person left is the guy responsible for pushing the button. He clambers into a steel can which has been placed a mere 20 meters from the blast site. If all goes to plan, he'll bring down a 16,000-ton wall of granite at the flick of a switch.
Clear, mate.
Yeah, clear down here. Yeah, we're clear here, right?
Let it go.
Once the dust and debris have settled, the explosive specialist needs to check that all the charges have gone off. Now that the granite's out of the rock face, it still has to get to the top of the quarry. And that's an 18-minute uphill climb, which is tough because fully loaded with granite, each of these trucks weighs an incredible 100 tons. Waiting at the top of the quarry is the biggest, meanest crusher in Europe, capable of grinding down 30 tons of granite in just 20 seconds. But to make the world's biggest brick, you need more than rock. The secret life of concrete, next on How Do They Do It? To make the world's biggest brick, you need a heck of a lot of crushed rock. But to get the rock to stick together, another man-made material is needed: cement. It's a dew-soaked early morning on the Staffordshire Moorlands in England. This huge factory churns out millions of tons of cement every year. First ingredient, limestone. Like granite, this is blasted from a quarry. Then it's sent along a conveyor belt at a rate of 1,000 tons an hour to the cement works. The limestone is ground and mixed with another rock called shale. The result is this powder, known as raw meal. The raw meal works its way through a series of cyclones, each one getting hotter and hotter until it finds its way into a huge 58-meter-long kiln, where the powder is cooked at 800 degrees Celsius. At this temperature, a chemical reaction between the limestone and shale binds them together. This chemical reaction lies at the heart of cement making. It's in the kiln at this temperature that the raw meal transforms into what's called clinker. But there's a problem. When clinker is ground into a powder, it flash dries. In other words, it sets within a matter of seconds, which is no use to anyone. To prevent this happening, one final ingredient is added to the mix. Gypsum is a stone which acts on the clinker like a delay switch. The gypsum and clinker are ground in a huge rolling oven and finally emerge as cement.
Nearly 20 million tonnes of cement produced in my lifetime here. And the funny thing is, for a complex process, all you end up with at the end of the day is a bag of dust.
That bag of dust is essential to the Kugera. Without it, it cannot produce its giant blocks. But there's another problem. Concrete doesn't take long to set, which means the aggregate, sand and cement can never be mixed together more than 5 kilometers away from where it's being used. Any further, and it's too late. Game over. Can't be poured. So when it comes to mixing and laying concrete, once you've started, you can't stop. It continues day and night, come rain or shine. If the liquid concrete is poured too quickly, it won't set properly. Too slowly, and it sets before it can bond with the next layer. And if there's just one slip up, that's it. It can't be mended. The entire 30,000-ton brick has to be scrapped. So, for 10 days and nights, concrete has continuously been poured from mixers working round the clock. Finally, the block is complete. But there's one final hurdle. The brick is in the wrong place. So how do you move a 30,000-ton concrete block? 2 tugboats arrive to tow the block into position. But how is this possible? Time for some ancient history. The Greek philosopher Archimedes discovered when he climbed into his bath that the water level rose, lifting up his ancient rubber duck in the process. Well, strange as it may seem, the rubber duck principle also applies to this mammoth block of concrete. There isn't a bath, but even in the open sea, there is a similar local effect. The Kugira's twin hulls are hollow, but are currently being pumped full of water. As the ship sinks, the water displaced should lift the massive brick off the seabed, and thanks to hollow chambers inside the brick itself, the thing should float. Now this colossal brick can be towed away. As the water floods out of the Kugira's